This is the lesson for Chapter 6, Section 4, Volume of Spheres. And if we take a look at this little drawing I had done here, if we have two cones whose height and radius are equal to the radius of the half sphere or hemisphere, if we had this full of water, full of sand or something, if we emptied it out into this hemisphere, it would exactly fill this hemisphere. And so if two cones, again with the radius being the height, but then the radius of the circle that represents the cone's base is the same as the radius of the hemisphere. If that's the case, then two cones exactly fill one hemisphere. So that means that if we had four cones will fill a whole sphere. And so that's why we take this formula for the cone. Now again, typically the cone is 1/3 pi r squared times height, but the height is the radius. And so we have two radii and then one radius here, and that makes 3 altogether. So radius cubed, and then 4 times a third makes 4/3. So 4/3 pi r cubed is the formula. And so that's what we're going to end up using to come up with the volume of these problems here. So first of all, they give us the diameter of this ball is 10 inches. So whenever we are given the diameter, we're going to end up having to modify that so we can find the radius. Again, the radius is always half of the diameter. And so if I take half of 10, that's where I'm getting 5 inches for the radius. And so now we'll go ahead and write our formula down. The volume is 4/3 pi r cubed. And we'll take this 5 and substitute it in for r in the formula. So 4/3 pi times 5 to the third power. Well, 5 to the third power is 125. And then I need to multiply that 125 by 4/3. Now notice 125 is the same as 125 over 1. So when I'm multiplying the 4 by the 125. And that's where I'm getting 500 from. And so 500 over 3 pi. And so now I'm going to use the calculator and enter 500 divided by 3. And that gives me this number here. So that's where I'm getting the 166.6 repeated, and then I'm going to multiply that by pi. And so I'll take the calculator again and take that same number. Again, I did not clear that number. I use that same number, and then I press times by 3.14 for pi. And that gives me this number here. So let's see what that was, 523.3 repeated. And this is going to end up being, and I think it says round to the nearest cubic inch. So let's just round that to, since the 3 is not big enough to round that up, we're going to keep it as 523 cubic inches. So let's take a look at the next problem. The difference between this one and the last is it gives us the picture, but it also only gives us the radius. So we're ready to go ahead and substitute the numbers into our formula. Now when we do this, the only number to substitute is 1, just the radius. And so I've got 4/3 pi times 9 to the third power. And so when we do that work, we can take 9 and cube that number if we want to. And so we've got 9, and then let's see if we can find that button here. Yeah, 9 to the third power. And so notice this XY button is what I end up using to come up with that. Now if you didn't know that, you could just do 9 times 9 times 9, and that would give us the same answer there, 729. So now we've got 4/3 pi times 729. Now 3 is going to go into 729 because 3 goes into 9. And so I'll go ahead and do that work now. So I'll times that answer by 4, and then I'll take that number and divide it by 3. And that's going to give me 900, and that number was 72 pi. So now we'll take that 972 and we'll multiply it by 3.14, and that's where I'm getting this number, 3052, and that number was 0.08, so 8/100ths. And this problem doesn't say round to the nearest cubic inch, but if we did round to the nearest cubic inch, I'll go ahead and do that. I look at the 0 and it's not big enough to round that up, so I'm going to leave it as 3,500 or 3,052. And these are inches to the third power. So looking at our next problem here, I changed this number to 2. So if you take a look at the notes template, this would say 5. So I ended up changing it to 2. And that's my radius. And I've got a height of 10 inches for the this cylinder. Now the radius of the sphere is exactly the same, since it looks like it fits exactly in here, is exactly the same as the radius of the cylinder. So what we want to do is we go ahead and put this ball inside here, and if it was filled with water, a bunch of water would spill out. It would displace that water. Well, same thing here. The air is going to spill out when we go ahead and put this object, this sphere, inside the cylinder. And so that's what they're asking for. How much air, the amount of air that was displaced, how much is taken away, what volume is left. So the way we're going to do that is we're going to take the volume of the cylinder and we're going to subtract the volume of the sphere. And so when we do that, we'll go ahead and fix that real quick. So we've got the volume of the sphere and the volume of the cylinder. We're subtracting the two. And so I'll write down the formula. It's pi r squared times by height for the volume of the cylinder. And then for the volume of the sphere, it's 4/3 pi r cubed. And so when I go ahead and substitute the numbers in here, I have pi times 2 squared times 10, and that goes in place of the h, so I'll rewrite that. And then minus 4/3, and then I've got pi, and then 2 to the third power. So I can go ahead and do some work here. This is pi times by 4 times 10, which is 40 pi. And then over here, I've got 4/3, but I've got to do that 2 to the third power. And so that makes 8, and then times by pi. So when I multiply this out, it's 32/3 pi. So I just multiplied 4 times 8, and that's where I'm getting that 32 from. So now I'm ready to do some subtraction. So I'm going to go ahead and divide that 32 by 3, and that gives me this number here, 10.6 repeated. So 10.6 repeated pi, and I'm taking that away from 40 pi. So I'm going to go ahead and use that same number, and I'm going to make that one negative, and I'm going to add, and then I've got 40. And this is going to give me 29.3. So 29 and 1/3 is what that is, since that 3 repeats, pi. And so now I can go ahead and approximate this by taking that value and multiplying that by 3.14. And so that ends up equaling this number here, 92 point, that number was 106 repeated. 106 repeated. So I'm going to go ahead and round this number. Let's go ahead and round to the hundredths place this time. So if I look at the 6, that 6 is big enough to round this up, and so I've got 92.11 inches to the third power is how much is being displaced. We'll say air, we'll say of air, so let's go ahead and fix that real quick. And so 92 and 1100 cubic inches of air is displaced by the sphere. So let's take a look at the next problem here, and we've got this one. It says, if you triple the radius of the sphere, how does this affect the volume? So let's go ahead and start off with the volume of a sphere. It's 4/3 pi r cubed. Well, what they said is they want us to triple the radius. So if we triple the radius, it would be like this, 3 times the radius. But since I want to make sure I triple the radius first before I cube it, I need to make sure that I put that 3 in parentheses. Well, if I go ahead and do this work here, using the rule of exponents, I have to triple, or I have to cube each of the numbers inside the parentheses. So this would become 3 to the third power r to the third power. Well, 3 to the third power is 27. So 27 r to the third. So basically, if we triple the radius of the sphere, the volume is going to end up being 27 times larger. And so that's what we get from this formula here. So we'll say tripling the sphere, or the radius, tripling the radius would make the volume 27 times larger. So this next problem is very similar to the number 3 that we ended up doing. It says find the remaining volume after this ball is placed in the cylinder. And the ball fits directly inside and there's no space left. And so this is supposed to be, instead of hole, whose diameter is the same as the cylinder, and it's placed inside this cylinder. And so what we've got is a radius that we're going to end up needing, and that radius is half of this diameter, which is 5. So we're doing the same thing. We're going to find the volume of the cylinder, and we're going to subtract the volume of the sphere. And so we've got pi r squared times by the height. We're going to subtract that 4/3 pi r cubed. And so when we do this, we've got the radius, which is 5, squared times by 10, which is the height. And here we have 4/3 pi times by 5 to the 3rd power. So doing some work here, 5 times 25 times 10 gives me 250 pi. And then on this side, we've got 4/3 times pi times 125. So when I multiply the 4 by 125, I end up getting 500 and then thirds pi. And so when I do that on the calculator, oops, let's fix that. So when I go ahead and do 500 divided by 3, I end up getting this 166.6 repeated, and I've seen that number before. I remember it from a previous problem. And I'm going to subtract that from the 250 pi. So my calculator allows me to put a negative sign in front of it, and I'm going to add that 250, because if I have opposite signs, I end up actually subtracting. That gives me 83 1/3 pi. And so now I just have to multiply the 83 1/3 by 3.14. And that ends up giving me 261. Let's see what those last numbers were. 0.6 repeated. And so let's say I wanted to round to the nearest tenth this time. So if I do that, I'm going to add on 1 extra 6, and I'm going to round that up. And so this would end up being 261 7/10 inches to the 3rd power. And this is the amount of volume remaining. And so those are the types of problems that we'll end up seeing on tonight's homework. Good luck.